Okay, so we will start now. So as you all know that today's assignment is primarily related to graphs. So, uh, so as there was a request, I think in the theory class that you have labs, you have tests this week. So we have slightly extended the deadline, but this is not going to happen from the next um, uh, test slots. So this lab has to be done within the lab hours. So this is one special uh, change that we are making to this particular assignment. But please take a note that from the next assignments, whenever there is an overlap with the test week, there will be no changes in the submission schedule. So the submission will have to be done during the lab hour itself. Number one. Number two, I think there was a request from some of the students to show a detailed implementation of one graph algorithm, maybe in C or C++. This is what we are going to do immediately after I have released the assignment today. And then once that is done, that tutorial is over, um, you can start doing your assignment in the lab, and like whatever you finish, and then like you can go back and try and then submit by end of day Sunday. So both the HackerRank and the Moodle will remain, or I mean, active till that time point. So please make it a point to submit by Sunday end of day. Okay. So now coming to today's tutorial. So so imagine that you are in a multiverse. So something similar to, uh, I think many of you have already played this game. So something similar to the Pokemon multiverse, and you want. So the idea is that you want to beat any of the gym leaders, okay, in this universe. So uh, you will be able to rule an universe only if you have built the um, the leader, okay. However, there are some rules. What are the rules? So to be champion of a particular universe, you need to beat all the gym leaders in it. So there could be multiple gym leaders, okay, and you need to beat all of them. And there is another constraint which is even more challenging. That is, you cannot, you know, randomly challenge any of the gym leaders. If you have to challenge one of the gym leader, you have to make sure that you have defeated all those that this gym leader has also defeated. Okay. So the game history is given to you, and you need to first defeat all the players that this particular gym leader has already previously defeated. Only then you can challenge this person and then play the game and defeat him or her. Okay, so now there are certain other good things that you have at your disposal. So the first thing is that you can assume that you have the most powerful Pokemon. That means that given a chance to fight, okay, given a chance to fight with any of the gym leaders, you are fully sure that you will win. Your Pokemon will win. Okay. So irrespective of like who is the opponent. So as long as you are able to challenge a gym leader, you should be able to defeat that gym leader. But the issue is that the gym leader might have many other people whom he or she has defeated, and therefore you have to first defeat all of them and then go and challenge this challenge a particular gym leader. Okay. So, and as I say, you are provided with the full list of fights, that is the game history is there with you. And for simplicity, you can further assume that uh, between any two opponents, there will be at most 2 fights and the outcomes are different. Okay, so there is at most 2 fights and the outcomes are going to be different for these 2 fights. So say that, so like realizing this with an example, it would look like this. So say A and B are two players, so there could be two possibilities. Either A and B have not faced them yet. Sorry, there could be three possibilities. The second is there is a single match that has been played between A and B. Okay, and there has been two matches that have been played between A and B. Okay, and each one of them won one match. Fine. So these are the three things that could happen, right? So like no other alternatives is allowed. Fine. So this is an assumption that you can make. So first is A and B might, so if there is a two-player situation, then there could be any one of these possibilities. One is they might not have faced them at all, or there might be a single match that have been played between them, or there have been two matches played between them, one won by each one of them. Now the question is that whether it is possible to become the champion of this Pokemon universe. Okay, and if yes, then so try to think out like in uh, graph terms whether you can formulate a problem which can tell you whether this is possible or not. And then if it is possible, then you have to provide a sequence of players that you can face, okay, to become the champion. So now there could be multiple such sequences. Okay, we are happy if you can report any one of them. So there could be multiple sequences in which you can defeat the players to finally win the universe. Any one of these sequences is perfectly fine. Okay, you probably understand where the problem is going. Okay. So now there is, say, an additional constraint on top of all this, which makes the issue a little bit more challenging. So what is it? That you might be requiring quite an amount of time to reach a particular universe, and by that time the person whom you thought you would challenge might have already played a few other games. Okay, and in process of this, what has happened is that you are in a trap, and you are not able to actually challenge any further person so that you can win the universe. Okay, that kind of a situation might also take place. Now you have to find out what is the maximum number of matches that you can afford so that such a situation does not arise. Okay, so how many matches can you afford so that the situation where you will not be able to challenge any of the players will not arise. Okay, so the maximum of such matches, that is what you have to also estimate. Okay, so there are three things. First of all, you have to ascertain whether such a um, championship exists or not. Second is you have to uh, identify the sequence of players whom you can beat in order to become the champion of the universe. Now, there could be multiple such sequences. Reporting any one of them is perfectly fine. Now, the third thing is during your challenge time, some of the gym players, my gym leaders, might have played with some other people and have defeated them. Now, at some point, it might as well be possible that you are not able to challenge any further gym leaders. And at that time, you have not also been able to conquer the universe. So this means that you are in a trap. So you have to identify how many maximum matches are possible before such a situation arises. Okay, so this is basically the time limit that is set for you. You have to defeat everyone by that time. So that is the worst possible time by which you can, or the worst possible time that you can take in order to win the universe. So now there are some boundary conditions. So number of players, you can assume it is a number between 1 and 10 power 5. Similarly, number of matches is also between 1 and 10 power 5. And of course, like, you can always imagine this as a graph problem, as I have already said, and it is specifically mentioned that you have to solve this problem using BFS, okay, and a queue, and you cannot use STL. So we have provided the queue structure. You will have to use this queue structure to implement BFS. So your BFS implementation should call a queue that has the queue structure. Okay. So this problem you can solve using a BFS along with a queue, using a BFS traversal implemented through or simulated through a queue, and you have to uh, do this using a specific structure that is specified here. Okay. Now let us see like how the input will look like. So the input will look like this. So the first line will have N and M. So N is the number of players that you have to challenge. Okay. And M is the number of matches that have already been played. Okay. So here M is 1 and N is 2. So there are two players whose IDs, actually the player IDs run from 0 to N minus 1. Okay. So there are two players and there will be M such history. Okay. Since M is 1 here, you have one history and you read this tuple 0 space 1 as the first player, in this case 1, has beaten the second player. Okay. In this case, sorry, the first player is 0 in this case. 0 has beaten the second player 1. This is how you read it. Okay. So the first player followed by the second player in this tuple indicates that the first player 0 has beaten the second player 1.
Excuse me, sir.
Yes.
The paragraph below says last line is first player beaten by the second player.
Yes,
Oh,
sir.
okay. Okay. Sorry. So I was telling the correct thing earlier. So yes. So first player is beaten by the second player. So that means uh, is beaten by. So that means 0 is beaten by 1 in this case. Okay. So 0 is beaten by 1. So now, given this, what would be your output? So the output is like this. So what is this telling? So since there are two players, you have to play with them. Now, with whom will you play first? In this case, with whom you will have to play first and defeat?
0.
So, okay. So 0 has to be played with and defeated. Okay. And then you can play with 1. Only when you have played with 0 and defeated 0, then you can play with 1. Okay. And since you have the most powerful Pokemon, 0 is automatically going to be beaten, and therefore you are going to have a solution. Okay. Now, how many matches are maximum number of matches are possible, okay, before this chance is gone from you?
Maximum 2 matches.
Maximum 2 matches. So another match is possible. What will be the outcome of the other match?
So then 0 will beat 1 because it is given
Yes.
that if 2 matches are played, 1 will
Yes.
beat.
So the other match will be 1-0, right? In which what is happening?
0
One is
beats 1.
yeah, 1 is beaten by 0, or 0 beats 1. So if this happens, then what will happen?
A cycle is formed, so we cannot
So that
go to either one.
you cannot challenge any one of them. You are in a trap. Agreed?
Yes, sir. Yes.
Yeah. So that means you cannot allow this to happen. So therefore, in this case, the maximum allowable match is 0. You cannot allow any other match to happen. Right? So if any other match happens here, then you are not going to win this universe. So this is another example. There are 4 players and also 4 matches, and the sequence of matches are as given below. So whom will you have to defeat first?
Three.
First you will have to defeat 3, right? Then you can beat 1, 2 or 2, 1. So you see, there could be 2 sequences possible. And then finally you beat 0. And here the maximum allowable match is 2. Okay.
Sir, how is it 2, sir?
Yeah, you tell me. You have to also tell the sequence of what are the matches that can. So basically, whenever there is a cycle that is formed, if a cycle is formed, immediately you are trapped. If 0 beats 3, okay. If 0 beats 3 and 1 beats 2 or 2 beats 1, if these two happens, then you will not be able to challenge anyone, right? There will be a cycle formed. Agreed? Either one of these happens and this happens. So two matches, one after the other, and no other matches will be possible because of that constraint given earlier. If a pair plays, then the outcome can be either one of those three. Okay, either they have not played, or if they have played, each one of them have won one game.
Sir, if 0 beats 3, then how a cycle is formed?
It's not formed.
So cycle is not formed. That is why 0 can beat 3.
That is why. So 0 can beat 3, then the cycle will be formed.
No, sir.
Sir, if for
So if 3 beats 0, then the cycle will be formed. 0 can beat 3 because 0 is anyways after 3.
Wait.
So basically, we need to find how many.
So you
People
need
can
to
beat each
find
other.
one. You need to find one cycle. Okay. You need to find the cycle is formed or not.
Sir, any match between a person who has occurred later in the queue can happen, sir. Like, because anyways we are having the match with 0 later compared to 3. So even if 0 beats 3, it doesn't matter.
No. So if 3 beats 0 and then 0 beats 3 again.
3 beats 0 will be a problem, sir. But 0 beats 3 can happen. That's an extra match.
Yeah. So no, I am always mixing up the conventions. What is 3-0?
3 is beaten by 0.
Yeah, 3 is beaten by 0. And this is so that is what 3 beats 0. No.
No,
This
sir.
is 3 is
0
beaten by
beats 3.
so 0
sir.
beats 3. This is 0 beats 3. Yeah, 0 beats 3. And this is 3 beats 0. Now, now let us see what will happen if we have 0 beats 3. Okay. Sorry. No, 3 beats 0. And 2 beats 1. Then
Sir, in this case, there is a cycle.
there
Yes,
is a
sir.
cycle. Yeah,
Yes.
there is a cycle. This is the case where there is a cycle and you cannot proceed the game. So there is this. So Origi, there is a printing mistake here.
No, sir. We need to find matches which, even if they occur, there is no cycle formed.
Okay.
Yes,
So
sir.
this is
Yes, sir.
yeah,
Yes, sir.
yeah. So this is 0. Yeah. So basically these are the matches possible. But if this is a match happening, then you are gone. You'll be trapped.
Yes, sir.
Sir, can we print these matches in any order? That is, can we print 1-2 first and then 3-0?
Yes. Any order is fine.
Okay, sir. Thank you, sir.
Any order is fine. And this one, basically you will have, in this case, there are 2 games and 2 players. So this was the situation that I was telling in the beginning. So this is, you are trapped. So in this case, you have to print a message like this. Okay, it's not conquerable. Fine. Is this clear? Is the question clear?
Yes, sir.
Yeah. So you identify what will be needed to done. Where is this problem going? Are you able to think where this problem is going?
Yes, sir.
Yes, sir.
Okay. Okay. So for those who are still thinking, this is a topological sort variant. With certain constraints. Okay. Topological sort variant with certain constraints, and you have to do it with BFS. Okay. You have to implement the topological sort with using BFS, and the queue structure we have given, we have provided, and there is an additional thing. So topological sort typically happens on a DAG. Now here lies the clue related to how you are getting trapped. Okay, so this dagness and getting trapped are related. Okay, any questions relating the assignments? So you have to print the sequence, the number of matches, okay, the number of allowable matches, and then the possible games, which will still keep you away from the trap. Okay, any questions? Fine then. So now, then we can switch to the basic traversal code. So, Pavan, are you here?
Yes, I'm here.
So, can you please now make the assignment visible?
Yes, did that.
Okay. Okay.
Sir,
So
will time complexity be a matter over here?
we have not asked anything related to time complexity in this, but of course, like these are design questions. So this is a design solution that you will prepare. And all of these algorithms have their own known time complexity. You should try to remain within those bounds. You know what is the time complexity of queue construction, queue modification. You know what is the time complexity of BFS. So you have to keep yourself bounded to those. Fine. So now Orijit will start demonstrating the code, and after that you can start doing your assignment. So Orijit, I have made you the presenter.
Okay.
So I will now.
Sir, am I
stop.
audible?
Yes, now I will stop sharing my screen, and you can start sharing your screen.
So okay, hope so the screen is visible. So basically
Yes,
this
it is
is just,
visible.
so basically this is just in simple C code for DFS.
So we'll just going through this code only. So you can see we just use like we use C, just those two header files, no C++ and HTL. So in the assignment you should not use HTL. You just stick with basic C or C++ header files only. So okay. So I think you know this kind of thing. So basically we just need to define the structure here. So we define the structure node we have a data part and the pointer for the next portion. And so as we are implementing DFS, so we have some functions for pushing and popping, and another function is for DFS only. So okay. So this portion is starting. So we are just inside the main function. So suppose just take an example. Suppose we are doing this one zero. Just taking a small toy example. So don't waste too much of time. Okay. So here the number is 3. So the total number of node is 3. But then what is the adjacency matrix? The adjacency matrix is, so there is 0 1 1 0 0 1 and then 0 0 0. So basically in this line, so you are allocating the adjacency matrix with the size of like this is a num cross num matrix. So you are doing this in here. So after that you are taking the input, like basically you are populating this table here. So everything is done. Now you can start the DFS traversal. So before that you are just passing 3 things into the DFS function. First thing, like your source vertex. So suppose we are using 0 as a source, and then this is the total number of nodes, and this is the adjacency matrix. Now this is the sample structure I am defining with this. You can do with your own thing. So basically it is possible that you are not passing total number of nodes, but you are just like calculating from this adjacency matrix. So for simplicity I am just passing the number of nodes here. So basically what is the function in the DFS function is that, so you are allocating a simple like initial stack with null pointer, like this is the initialization of the stack, and you are doing also another thing, like you are making a visited array. So basically, so there will be a visited array with 3 elements, so 0 1 and 2, and at the initialization like all the values will be false or 0, anything. So implying that these nodes are not visited. So in this line you are doing this thing. So basically you are initializing the visiting array. Then what you are doing is that, like, you are adding your first node to the stack. So basically we are if you remember, we are passed the 0 as a source node to our DFS function. So basically to remember the structure, I just drawing the so so in the stack yeah, so basically in the push function, so we are passing the address of the stack and the source node. So basically what it will do, it will push the element 0 to the stack. Now if you want to see what is the like that structure of the push function, you can see. So I have defined this thing. So this is the push function. So I think you know what is the double pointer, why you are using double pointer. You can also get with single pointer, but then you have to extra do few things. So I think I will not go into that. So we are passing the double pointer and we are passing the value, and this function will push this element to the stack. So So if it is returning like if it is successful, then like these things will not call, else it will say that the mallocation is failed and it will return. That is all. Okay. Now this is our main loop. So we have our source vertex into the stack. So stack is not null. So we are popping our first node from the stack, which is 0, and like we need to check, okay, so 0 it already visited or not. But we know in the visited array, so basically the visited array is like 0, 1, 2. So all are 0. So 0 is like still not visited. So we just go there and change it to 1, and we will print it. So we'll print the first element. So this is our first DFS element. Not 0, it is 0. And what will our next step? Next step will be, we will go through all its neighbor and push push it to the stack. So what are the neighbors of 0? 0's neighbors are 1 and 2. Okay. So before pushing into the stack, we need to check, okay, so is 1 or 2 is already visited or not. If visited, then we will not put into the stack, else we will push that into the stack. So 0 is already popped, so there is no 0 now. So I just put 1 and 2 here. Okay. Again we'll these things are happened. Again we are come here. So while stack not equal to null, so stack not equal to null, so we're just popping the second element, which is 2. Okay, and we are saying that, okay, the visited of 2 is 0 or not. It is 0, so we change it to 1, and we are printing 2. Okay, and next we will go to its neighbor. Now what are the 2's neighbors? There are no neighbors of 2, so we are just there are no things to do in this here. So in this loop we are just getting back. Now there are only one element left into the stack, that is 1. So again we need to check in the visited array, it is already visited or not. It is not, so we are just doing 1, and we are printing 1 here, and we will again check its neighbor. But if you check, 1's neighbor is 2, but 2 is already visited, so we will not push into the stack. We will get back to the while here. But the thing is that now stack is empty, so we'll like this loop will break, and we'll get back to our main function. Okay, so we are getting back here before getting, so and so we are in between, we are printing this 0, 2 and 1. So this is the DFS sequence: 0, 2 and 1. Yeah.
Explain malloc failed part.
Yeah.
Like why it is printing malloc failed.
Yeah. What?
Explain it why it is printing malloc failed.
Yeah. Basically, if you like, what we are doing in the push function. In the push function, we are okay. So just go to the push function. So in the push function, what we are doing, we are creating a new node. So with the help of malloc. So basically, suppose we are just want to, like, this is a stack. Stack is like, this is the stack position, and now we want to push 2 into the stack. Okay. So what this function will do, it will create another node. Okay, and try to insert 2 into that. So basically, it will allocate another memory here and want to push 2 here. Now the thing is that if the allocation failed, this allocation will fail, then how will you insert the 2 and all these things? So all these things will fail. That's why you are just, this is an cautionary message. So most of the time it will not fail. This is just an like try and catch, like some kind of protection to your code. If something wrong happens, it will, you came to know, okay, so malloc is failed. But most of the time it will not fail. I'm just like writing it to for the sake of conclusion. So it is not necessary. Like if you run the code 100 times, like maybe 100 times you will not, these lines will not execute. But who knows, maybe one time the malloc failed and your code will fail. So for this, like for this type of short type of code, it is not matter. You will know where the things are going on. But if you write long, like 2000 line, 3000 line of code, then this kind of error handling will help you to check why things are wrong.
Okay.
Okay. Now there is a problem. So can you see the problem with this DFS algorithm? Suppose suppose this is our graph. So we have taken this is our graph. But what happens if this is like this is the graph? So suppose this is our new graph. Basically, this is not a graph. This is forest. This is a connect like this part. Tree is not connected with any of this. But if you run this graph with this algorithm, like is it possible to like reach 3? Now it depends. If you start the DFS with 3, you only get 3 as a result. If you start with 0, you only get 0, 1 and 1, 2 as a result, but you will not get 3. Okay. So basically with the source vertex is like it depends upon the source vertex, and it will not get all the nodes of the graph as a DFS result. So this algorithm will not like work for this kind of thing because this graph is not connected. So what is the workaround to do the DFS this kind of graph?
Start DFS from any unvisited node.
Yeah, so basically if you just need to write a loop. So just hold on. So the code will be the same, just you have to take care 2 things. So in the main function, you need to call like this. You need to go through all the elements. So basically, what are what is the graph that we have talked about? So basically 0, 1, 2, and this is 3. Now what is the adjacency matrix of this? 0, 1, 2, 3, 0, 1, 2, 3. Now what is like maybe the value is 0. Now if you do this thing by this loop, then if some nodes are not connected, but when you are looping by this node thing, so you are first taking all these things for 0, then 1, then 2. So sometime you need to go ahead and do the DFS. So these kinds of loop will help us. So for this unconnected graph, you need to do it by loop. So you need to go through all the nodes one by one and then call the DFS if that node is not visited. Then it will sort your problem. Else the whole code will be the same. This is the thing. So is there any question about this thing?
Sir, what is that visited in this line? DFS I comma visited.
Yeah, this is the function. Each time you need to call this function. So visited is same thing. So this is our visited array. So last time that we have created the same thing. We will create our visited. So there are 4 elements. So 0, 1, 2, 3. So at the beginning.
So it's a pointer to that array that is being passed.
Yeah. So we have.
Yeah, got it. Thank you.
Also, sir, why shall we use head star star head?
Okay, so the double pointer thing.
Yes, sir. It is not a matrix. We are using a stack, right?
Yeah, this one.
No, sir. Not for the matrix. For the stack.
Okay. This thing, the double. Okay.
Yes.
So,
Yes.
So do you know, like, have you seen this thing? So, the swap function, if we want to swap to variable a and b, if we call this function like suppose in the main function we have a equal to 3 and b equal to 5, and we have write a swap function outside this main function, and we are calling swap a comma b. Have you seen that these things are like, if you want, like if you print this a and b here, what will be the output?
They won't be swapped.
Yeah, they will not change. Why they will not change? Because you are not passing the address of a and b, you are just passing the variable. So suppose in the main function, so suppose this is the a and this is a's address, and in a here 3 is put, and this is b, and it, like suppose b's address is 500, and here. Now when you are passing like this kind of thing, so this thing, so what happened? So in the function memory, so suppose this is the swap function. Okay, this is the swap function, and it has its own memory, and its own memory. Suppose now what happened? So it will create two variables a and b. Okay, that's fine, but the address will be different. It is not 300 and 500. It will be something like 600 or maybe anything 700. But the value will be the same. Value will be copied, but the address will be different. Now, if you swap this thing here, it will not reflect. It will not reflect in the main function because it is not like doing anything with the address. Okay. So same thing happens here also. So what is the head function? Suppose, okay.
Okay, sir. Here we are changing head, so we need
Yeah, head pointer. So we need to pass its pointer so to change it itself. So you can also go with like this kind of thing. So head, only head, but then you need to return it. Like you need to return this address, and you need to catch it into the main function. So you can check it. So you have to do this kind of thing. You can go with single pointer, you can go with double pointer, but this kind of thing, double pointer will help because it is unnecessary, like avoid like such kind of thing. So if suppose you forget to catch this return thing into your main function, then your system will like fail. This kind of things are secured. Use double function, change through addresses, it will like secure things. You need to do it. But before you use the double pointer, you need to understand its concept, because if you don't understand the concept and you use double pointer, then it will do massacre. So before doing this thing, so just understand where you are using double pointer, where you are using single pointer. That is it. Anything will work, but you need to understand the concept. Okay,
so basically you have to understand the distinction of the address of a stack element and the address of the stack. These two things are different, and these two things are like handled with one with a double pointer and the other with a single pointer.
Yeah, because like in the main function, it has its own address space, and now if when you are calling some function, it has its own address space. So you cannot change anything from here. So you need to pass its address here, then you need to change it to it address. Okay, so I think that's all for this thing. So if you want to know anything further for other questions, you can ask. Else,
yeah. So I think like if this is kind of understood, then you should not have much problem to do something similar for the assignment that we have given. So try with maybe initially a simple implementation of the queue, and then maybe you can use the specialized implementation, a specialized structure that we have asked you to follow. So use a simpler version which like helps you to do it like correctly, and then you can easily modify it to our or adapt it to our structure that we have specified. So one thing probably you have noted here we have explicitly used the stack data structure for implementing DFS, but as I told you in the class, you can just use the recursive, like inbuilt recursive structure of C++ to implement this stack, and therefore the stack operations get internally done just through the recursion for the purpose of DFS. That is also a possibility, but here this is an explicit mechanism to implement stack and use it for doing DFS.
Yeah, this is an iterative process. If you want
Note
to
that this kind of luxury is not possible for BFS. For BFS, you will have to always implement a queue. Okay, so if there are no further questions, I would now suggest that you start with your assignments, and the TAs will be here till 5 p.m. today, so you can ask questions if you face difficulty, but today's assignment is relatively easy. So I hope you will not face much hurdles except for like probably coding up the queue. So so best of luck. So, and start off with the assignment.
Sir, while implementing the graph, are we supposed to use one of the implementations from adjacency list and adjacency matrix, or
anyone is possible? Anyone is like acceptable. Just see the queue structure, what it is accepting.
Okay, sir. Okay. Thank you.